You will learn the best notes for BGP, so make a notes of all this in your notebook or come to channel anytime. These notes are best for person pursuing CCNA or CCNP or CCIE. Let's start. Order Gateway Protocol is an exterior gateway protocol used to exchange routing information between different autonomous systems, AS. It is a path vector protocol that selects the best path based on several factors, including AS path length, local preference, and MED values. BGP uses TCP port 179 to establish a connection between BGP peers. BGP are of two types: IBGP, used within AS, and eBGP, used between AS. BGP uses path attributes to determine the best path to a destination. Some of the most commonly used path attributes include AS path. The AS path is a list of autonomous systems that a BGP update has traversed to reach its destination. Shorter AS paths are typically preferred over longer ones. Local preference. The local preference is a value used to indicate the preference of a particular path. It is used to influence the selection of the best path within a single AD. Multi-exit discriminator. The MED is a value used to indicate the preferred exit point for traffic leaving an AS. It is used to influence the selection of the best path between different AS. Next hop. The next hop is the IP address of the next router that a BGP update should be sent to in order to reach its destination. To control the traffic or implement the policy-based routing, you can use refix lists, route maps, and AS path access lists. BGP confederations. In large BGP networks, the use of route reflectors may not be sufficient to reduce the number of BGP peerings required to maintain a full mesh topology. In this case, BGP confederations can be used to divide the network into smaller groups or subases, each with its own internal BGP. BGP route reflectors. In large BGP networks, maintaining a full mesh topology between all BGP peers can be impractical. BGP route reflectors can be used to reduce the number of required peerings by reflecting updates between clients and non-clients. This allows a network to scale more efficiently while still maintaining full routing information. BGP scaling techniques. Scaling BGP can be a challenging task, particularly in large networks with multiple routers and diverse topologies. Some common scaling techniques include route summarization, route aggregation, and BGP communities. Route summarization. Summarizing routes reduces the size of the routing table and the amount of routing information that must be exchanged between BGP peers. This can help to reduce the amount of processing power and memory required by BGP routers. Route aggregation. Route aggregation is a technique used to group multiple smaller subnets into a larger network address. This can help to reduce the size of the routing table and improve the efficiency of the routing protocol. BGP communities. BGP communities are tags that can be applied to BGP updates to provide additional information about the update. This information can be used to implement policy-based routing, filter routes, and control the flow of traffic.
Hi guys, my name is Ajit Srivastava and welcome to my channel. Today we will discuss about notes on OSPF, which is useful for person doing CCNA or CCNP or CCIE. Do not forget to like, subscribe and share with your friends. Let's start. OSPF is a link state routing protocol. 2. OSPF uses a hierarchy of routers called areas. 3. OSPF uses the Dijkstra algorithm to calculate the shortest path. 4. OSPF has a cost metric that is based on speed and bandwidth of the link. 5. OSPF routers exchange information about their connected networks using LSAs, link state advertisements. 6. OSPF routers send periodic hello packets to establish and maintain neighbor relationships. 7. OSPF routes have an administrative distance is 110. 8. OSPF traffic is multicast either to address 224.0.0.5, all OSPF routers, or 224.0.0.6, all designated routers. 9. The IP header of an OSPF packet specifies protocol number 89. 10. The OSPF process builds and maintains 3 separate tables. A neighbor table contains a list of all neighboring routers. A topology table contains a list of all possible routes to all known networks within an area. A routing table contains the best route for each known network. 11 OSPF forms neighbor relationships, called adjacencies, with other routers in the same area by exchanging hello packets to multicast address 224.0.0.5. Only after an adjacency is formed can routers share routing information. 12 OSPF router is identified by a unique router ID. Selection of router ID can be done as below. The router ID can be manually specified. If not manually specified, the highest IP address configured on any loopback interface on the router will become the router ID. If no loopback interface exists, the highest IP address configured on any physical interface will become the router ID. 13 By default, hello packets are sent out OSPF-enabled interfaces every 10 seconds for broadcast and point-to-point interfaces, and 30 seconds for non-broadcast and point-to-multipoint interfaces. OSPF also has a dead interval, which indicates how long a router will wait without hearing any hellos before announcing a neighbor as down. Default for the dead interval is 40 seconds for broadcast and point-to-point interfaces, and 120 seconds for non-broadcast and point-to-multipoint interfaces. Notice that, by default, the dead interval timer is 4 times the hello times. 14 Default priority on Cisco routers is 1. A priority of 0 will prevent the router from being elected DR or BDR, and DR election is not preemptive. 15 To establish OSPF neighbor adjacency, hello/dead timers, MTU, otherwise have to use IP OSPF MTU ignore, must match. Unique router ID is also required. 16 Routers in stub area can only be adjacent with the routers in stubs or totally stubby area. Routers in NSSA can only be adjacent with the routers in NSSA or totally NSSA. 17 OSPF sees secondary networks as stub networks and cannot make adjacencies over secondary addresses. 18 The only time that OSPF will form adjacencies between neighbors that are not on the same subnet is when the neighbors are connected through point-to-point links using IP unnumbered. 19 The primary interface and IP unnumbered interface will have OSPF enabled if a network statement matches the IP address of the primary interface. 20 An OSPF external route cannot use another OSPF external route as its next hop. 21 OSPF cost can be modified using interface bandwidth. Command 2 Interface IP OSPF cost. Command 3 Process autocost reference bandwidth. Command or 4 Neighbor cost. Command on point-to-multipoint non-broadcast network. 22 The internal OSPF routes can only be summarized on ABRs, whereas the external, redistributed, routes can only be summarized on ASBRs. 23 In NSSA, ABR with the highest router ID does the LSA 7 to 5 convert.